In the last video, we described acid-base equilibria, and now when this equilibrium is established, we can identify something called conjugate acid-base pairs. So I have written here a generic equilibrium expression describing what happens when we put an acid in water. Okay, our acid is going to be HA, which is our proton donor. Our base is going to be water, which is our electron pair acceptor. On the other side of the equation, we also have our acid, which we described, which is H3O+, and our base is going to be A-, because when we look at the reverse reaction, we also have a proton donor and an acceptor. This leads to something called conjugate pairs, where we have an acid, HA, and its conjugate base is going to be the A-. In addition, our base is going to be water, and the conjugate acid is going to be H3O+. We call these conjugate pairs. And essentially, if we have an acid and we want to go to its conjugate base, we can essentially identify what was removed, or we could remove or donate a proton. So the acid is HA. When the proton is donated or removed, we get A-. So to go from an acid, which is HA, to its conjugate base would be A-. In order to do so, we have to remove or donate a proton. To go from a base to a conjugate acid, we have to add or accept a proton. And in the process, or for this particular example, we have H2O liquid going to H3O+ in aqueous solution. Okay? Both of these particular reactions right here have to happen with each other. They can't just happen by themselves. Okay? We can't remove a proton without adding it to something else. Okay? So when the equilibrium is established, we have these particular conjugate pairs. Okay? So for example, if we have HCl, this is an acid. Our conjugate base then is going to be Cl-. If we have NH3, which is a base, the conjugate acid is going to be NH4+. If we have HS- as our acid, in order to get to the conjugate base, we have to remove a proton. That's going to be S2-. And if we have HS- acting as a base, H2S is going to be the conjugate acid, because going from a base to a conjugate acid, we have to accept the proton. So one thing you might kind of be curious about is, hey, wait a minute. Right here we said HS- is an acid, and over here HS- is a base. So which one is it, an acid or a base? Well, everything depends on the situation, and there's a definition called amphiprotic. And amphiprotic means that a substance that is capable of acting as either an acid or a base. And when we look at equilibria and equilibrium expressions, we're going to start digging into more instances where we have kind of shades of gray rather than just black or white definitions. And you can't just sit down and memorize things. You have to look at a particular situation to figure out if a substance is going to act as an acid or as a base. And this will lead us into the next video where we look at the relative strengths of acids and bases.